Welcome to the Yunikorn demo videos. In this video we're going to look at the scheduling in Yunikorn with volumes. We have 3 examples to look at. An NFS mount and 2 examples using EBS volumes in AWS. Both environments have been set up already and will run the current Yunikorn scheduler. The schedulers are up and running with the basic configuration as per the documentation, and to support volumes, the scheduler runs with the check volume binding predicate enabled by default. So the NFS example is using an NFS server deployed using an existing NFS server example. The Kubernetes environment is Minikube on OS X. The IP address of the server has been updated in the pod YAML already. The NFS server has exported the /export directory, and this directory will be mounted by the pod. Currently the directory is empty. After the pod is scheduled and up and running, we can check that this pod is using the mount point by looking at the data generated on either side. The scheduler is in holding pattern, waiting for a request to come in. At this point we can start the pod. The YAML file contains the volume information, and it will start automatically generating data in a file on the mount point. The pod will be scheduled and started. The scheduler will show the result of the schedule actions in the log. The only thing this pod does is generate an unending stream of data into a file on the mount point. When the pod is running, we can check that the 2 points, the NFS server and the pod that we have started. So the NFS server shows the file that we've created, and the corresponding mount point on the consumer pod shows the same file. First, let's check the producing side in the schedule pod generating a timestamp every 5 seconds in the file. So we're looking at the screen, and this is the file that's being generated. On the NFS side, we see the same info. In the file, we see the same timestamps coming back. And it will continue to generate data up until we stop the pod. So let's stop the pod. Some preparation. First stop the tracing, and then we can stop the pod. Just as we scheduled the pod, we remove the pod via the Kubernetes command line. The change will be communicated to Yunikorn via the shim. Kubernetes will remove the pod after that, and the cleanup will show the finished pod on the Yunikorn side. We'll have to wait for the pod to stop, and we'll see it being cleaned up in a bit. As soon as the command line returns, we have things coming back. Okay. That's the tracing on the side, Yunikorn side. And let's switch to the second example. The second example uses the EBS volume. Since we cannot use the volumes outside of AWS, we have deployed an EKS instance inside AWS. The dashboard and RBAC rules needed for the dashboard and the scheduler have been set up as per the Amazon tutorial. The scheduler is up and running with the basic configuration, same as in the previous example. The scheduler is in a holding pattern waiting for requests. No volumes or volumes claims have been created as yet. They will be created when needed. The first example will use an existing volume that we've created using the AWS command line. So here we see no volumes, no persistent volume claims. So let's create the pod. As mentioned earlier, this example uses a direct volume reference similar to the way the NFS volume is referenced. The volume will be bound and the pod will generate data in a file on the volume. The volume is not available, the bind will fail and the pod will time out. Let's check the data that will get generated on the EBS volume. So, going inside the pod, and similar to what we have on the other side, we should see a list of timestamps in the file, just in a slightly different location. The files exist, and if we tail the file, we see the data generated. The EBS volume is persisted. In this case, the volume has been used before to run earlier tests. All pods have a simple header as they write into the file, and we can show that fact here, and we can see that the pod has written a little header in the file and that this volume has been used in previous example runs. Okay, so this is the first example. We need to clean up a little bit because we're going to use the same volume for a next test. So again, this needs to wait for a couple of seconds. Okay, the volume, the pod will be removed, and as soon as we're done with that, we can do the next steps. So the PV that we're now creating uses the same volume that we've done before. That should mean that we see exactly the same headers that we saw in the previous file, and the file should already be there. So let's create the pod, and in this case we use a pod that has a PVC claim built into it, and we're claiming the same volume as that we've just created. The scheduler will run and make sure that the claim exists and the claim is bound, and we can see here all the predicates being run and information going through the system. Let's refresh so we can make sure that the pod is started. Yep, the pod is started, and we can now check the generated data. Since we know the file is already there, we go and check the content. We should see timestamp from the previous runs in the top, and then the little header and timestamps from this current run. As this pod has identified it with a slightly different header, we should be able to see the previous runs in the same file again. We'll do another bit of housekeeping, clean up what we've created, and we go on to the last example. So, clean up. Deleting the pod. Okay. So according to Kubernetes, we're done. Persistent volume is still bound. The claim still exists, so we're not done cleaning up yet. Okay, now we need to still wait a little bit. Let's refresh and see what we're up to. Yep. The volume is released, and that means that the pod should also be gone. Okay, now we can go to the next step, and we're going to create a new volume. For the last example, we use auto-created volumes using a storage class. The storage class must be set as the default storage class for this to work. The cluster must also have the default storage class admission plugin enabled. After we have the storage class, we can create the PVC and pod. The existing volume does not satisfy the requirements, and we should thus see a new volume in the system. So, let's create the pod. And creation of the volume can take a couple of seconds, and the pod will become available as soon as the volume is created and bound to the claim. This will show up in the pod state as the fact that it's the first fails, but then the claim will be retried, and in the meantime we should have a new volume created which is bound, and we see the volume going through in the schedule. Okay, so I'm not going to show any further details on what we've generated. The generated data is exactly the same as the previous cases, so I'll leave that up to you to go and have a look at. This is the demo for today. Thank you for watching.